Today, we're diving into a really wild idea. What if we could build our digital worlds not on, fragile trust, but on the absolute certainty of mathematical proof? We're talking about something called the atomic kernel.
You know that feeling, right? That little nagging doubt when you're deep in an online game, or maybe making a digital purchase, or just trying to sync files between two machines. Is what you're seeing really what's happening? Right. These are the symptoms of that fragility. One server tells you one thing, your app says something totally different, a transaction just poof vanishes into thin air, or a digital item you thought you owned starts acting weird. And that's honestly the perfect way to describe them. They're like phantoms, born from all this ambiguity, from systems that are just hoping everyone's playing by the same rules at the same time. These ghosts, they live in those tiny cracks of uncertainty. So that brings us to the really big question. What if we could just get rid of those ghosts completely? By building a foundation where agreement isn't something we hope for, but a logical necessity. A world where truth isn't some matter of opinion, but something you can actually prove. Okay, so to even start building a world like that, you need a common point of reference, right? Like a universal heartbeat, a steady, predictable pulse that everything can sync up to. And in this system, that pulse, it's not built from hardware. It's built from pure math. And this is where we get to the core idea. Think for a second about the quartz crystal in your computer CPU. It's not doing any complex thinking, right? It just vibrates. It oscillates at this perfectly steady rate, and everything else in the computer uses that pulse as its source of time. The atomic kernel, well, it's designed to be that exact same thing, but in software. It's not running your app, it's just providing that perfect, unchangeable rhythm for everyone. Now, this is where it gets really interesting. Let's compare this software clock to a physical atomic clock. An atomic clock's precision, that's a physical claim. It depends on the laws of quantum mechanics. But the atomic kernel's clock, that's a mathematical claim. Its drift isn't just tiny, it's exactly zero. Why? Because it's just a sequence of numbers. You don't measure it, you compute it. And here's the kicker. Anyone, on any machine, anywhere in the world, can compute the exact same sequence. It's verifiable with a machine check proof, not by calling some guy to recalibrate it.
Okay, so we have this perfect clock. Awesome. But what does that actually let us do? Well, it allows us to build a totally new kind of identity system. And the key insight here is brilliant. You solve the problem of forgery by splitting the very idea of identity into two separate parts: what something is and when it happened.
All right, let's break this down because it's super important. On one side, you've got the semantic identity, or SID. Think of this as the what. It's a unique fingerprint of an object's actual content. It's totally timeless. Then, on the other side, you have the occurrence identity, or OID. This is the when. It defines a specific instance in time by combining the clock position, the object's SID, and this is the crucial part, a hash of the previous event's OID, and that's what creates an unbreakable chain. So here's how that chain gets built step by step. Every new event, every single occurrence creates a new OID that is cryptographically locked to the one that came right before it. It's literally a historical chain. So what happens if you try to go back and change just a single detail of a past event? Well, its OID would change, and that would break the hash of the next OID, and the next one, and the one after that. The whole chain just collapses. Anyone can check your work by just recomputing the chain themselves. Forgery isn't just hard, it becomes mathematically impossible.
So this all leads to a system where the rules aren't just, suggestions. They are the law, a law written in the pure, cold language of mathematics. And this is a pretty radical idea in the software world. I mean, usually the code we run is the law, right? The code defines what the system does. But here, it's completely flipped. A mathematical proof is the constitution. The actual application code you write is just an implementation that has to obey that constitution. And if there's ever a disagreement between them, the code is considered broken, not the law. The math always wins.
Okay, now don't panic. We are not going to solve this equation. This is the actual state transition function, what they call the kernel law. The only reason we're showing it is to make one thing super clear. This isn't some vague philosophy. It's a concrete, written down, unchangeable mathematical rule that governs every single tick of that software crystal. So how do you actually enforce this constitution? It's done through something called the verification triad. First, you have the proofs. That's the formal mathematical contract. Then you've got gates. Think of these like automated police, constantly checking to make sure the running code conforms to the law. And finally, you have replay locks, which are these guarantees that a given input will always produce the exact same output, down to the very last byte, every single time.
Okay, let's take a breath. We've got a perfect clock, an unforgeable identity system, and a mathematical constitution holding it all together. So what? What does this actually mean for us, for the apps we use every day? And how does this lead to that dream of seamless adoption and participation?
The best way to think about it is like a skyscraper. At the very bottom in the bedrock, you have the foundation. That's the kernel law. All power, all authority flows up from there. The apps and user interfaces we interact with, they live on the higher floors, and they are fundamentally, absolutely constrained by the rules of that foundation. They can't just decide to break the laws of physics that are defined down in the kernel.
And this brings me to one of my favorite lines from all the source material. Your UI is just an opinion. Think about what that means. The app on your phone, the website you're looking at, it's just one possible view of the underlying reality. It's an interpretation. It literally cannot lie to you about the ground truth because you, or anyone else with any other app, can always connect directly to the kernel and verify that truth for yourself. The ghosts can't hide when anyone can just turn on the lights. So what's the first big payoff here for consumers? Perfectly replayable experiences. Because every single thing that happens is deterministic, it's derived from a starting seed and a tick number. Any event can be replayed with 100% fidelity. I mean, imagine a competitive game where a controversial play can be reconstructed bit for bit to see exactly what happened. No more arguments. Or a collaborative design project where you can rewind history perfectly.
Okay, benefit number 2 is a huge one, especially for creators and, well, for all of us as users. Remember that unforgeable OID chain we talked about? Because of that, ownership is no longer just a line in some company's private database. It becomes a mathematical fact that you can prove yourself, just by recomputing history. You don't need to trust a central company to tell you that you own a digital item. You can actually verify it yourself.
And this all leads to the ultimate goal, the thing that makes seamless adoption possible: participation without trust. When you don't have to trust a central company or a middleman, the barriers to entry just fall away. Anyone can participate. Anyone can build a new opinion, a new UI on top of this shared reality. You can join the network and verify everything yourself directly. It's not about getting permission, it's about computation. So that's really the final question this whole system leaves us with. It's a fundamental shift from building our digital worlds on sand to building them on absolute bedrock. And it really makes you wonder, if we had a digital foundation this solid, as reliable as the laws of physics, what new, incredible, maybe even unimaginable things could we finally build on top of it?